All right, question 3b. Again, my job is to get in there and start factoring. I see that the numerator is a trinomial. Okay, and then I see that the denominator is just a binomial. Now, as soon as I see that binomial, in my head I'm thinking, I hope this is a difference of squares. So just take a quick look at it here. It's not though. It's not a difference of squares. So then the only other thing that I could really be concerned about here is if it's got common factoring. And I should always be looking for common factoring anyway. But I take out the common factor of 2, and I'm left with, sorry, I'm anticipating the end of the answer, and I wasn't thinking about the beginning here. If you take out the common 2, that leaves you with 2x minus 1 in the denominator. Always remember to include that common factor that you pull out. It should stay there. It doesn't disappear, okay? Now, this gives me a little bit of an insight as to what's going on up top here. We should have done enough of these to realize that stuff that I should be expecting the same factor in the numerator as I get in the denominator, or at least there should be some overlap there. So already I'm anticipating that one of the factors up here is going to be 2x minus 1. Now let's just take a quick look here. Up here that's 2x squared plus 5x minus 3. Unlike the previous question, the 2 is not common to all of those, which means I'm going to be stuck with it in there. Now 2 is a prime number, so I'm just going to include the 2x and the x there. So I know when I multiply 2x by x, I'm going to get 2x squared. Now, I am anticipating that this is going to be minus 1. Now, this is a little bit of a cheat, really. I don't know that that's the right factoring, but I have a pretty strong indication that it will be. And then if this is negative 1, based on the original function here, this would have to be positive 3, so that negative 1 times 3 gets me negative 3 at the end there. Now, what I don't know is if I'm actually going to get the 5x there. So what I'm going to do here really quickly is just multiply that out. I'm going to get 2x squared plus 6x minus 3, and there's my 5. So that did work. Okay, so that is the correct factoring. Now I don't need that anymore. So just like I was hoping, the 2x minus 1 over 2x minus 1 becomes the 1. I'm left with x plus 3 over 2, which is true, but it's not equal to the original. They're equivalent. It's not equal until I state or include the restriction here that x cannot equal 1/2. Now notice there is no other restriction here. A question like this really is tempting for people to throw in another restriction. Sometimes people want to put in 0. Okay, 0 is not a restriction. X could equal 0. 0 plus 3 over 2 is just 3 over 2. Sometimes people want to say 2. Well, can't it not equal 2? Well, no. First of all, there's no variable down there. And don't say that 2 can't equal 0 because, well, yeah, of course it can't. It isn't. So that's not a restriction either. And the numerator doesn't produce restrictions either. If the numerator goes to 0, that becomes 0 divided by 2, which is just 0. Okay? That doesn't remember what I was telling you before. If I took all the money in my pant pocket and shared it with the class, everybody would get nothing. Because you can divide 0 by whatever number you want. You still get nothing. So that is it. That's as far as you need to go.